So I'm Emanuel Ott. I'm working as the Director of Customer Solutions at iMerit. And having spent the last 5 years working at iMerit and having kind of worked with a lot of global companies and players, whether it's kind of car manufacturers or satellite imaging companies, companies like Amazon in the natural language processing market, I got to kind of know a lot of insights into their training pipelines and how, in my opinion and based on my experience, things work very well and what we can improve going forward, especially with examples, as we heard in the morning, kind of biases getting bigger and getting more problematic if you scale. Very quickly about what iMerit is. We are a human-in-the-loop company. We're providing annotation services to different key players in the annotation or in the AI market. Our focus is, with our 2,000 employees, to drive positive social change and economic change. Our centers are across India, 7 out of them. We have 1 center in New Orleans in the US working on these, and 50% of our workforce are women, or over 50% of that. And so while kind of AI is, and that was the talk this morning, is transitioning jobs or taking jobs away, we as a company very much benefit from that, especially in the recent years with kind of over 2,000 employees right now who haven't had the jobs before. Now, what are we working on? We're working on different kind of use cases. I will use a computer vision one because it's dear to my heart and it's easier to explain. But we're working also in the NLP space and in the e-commerce as well. The challenges I'm going to outline and kind of the approach is pretty much applicable to all of them, but I'm going to use a computer vision one as an example. So again, I'm not claiming to be the expert in building machine learning pipelines, but I have a unique position to see a lot of different kind of companies approaching this topic and kind of seeing what worked, being very closely incorporated in the process, being kind of the humans labeling and producing supervised data sets. I try to kind of very simplify a standard when you start off basically doing your machine learning in a company pipeline. And what you're seeing is basically the 5 different steps here. You're starting with your requirements. You're moving on in the car example to kind of do your test drives with all the different sensors, doing some sensor fusion if necessary, or if you have kind of LiDAR on your cars, and then end up with kind of the data labeling job, which hopefully comes to us. Some QA, QC kind of involved, either also kind of outsourced or in-house. And then basically you're actually coming to what you actually want to do is, or you really want to do, is kind of building your AI model and training it in order to see, is your experiment actually working? There are different talks and papers around that on how much time it actually takes to kind of get to the point of the AI training or the machine learning. And estimates are between 70 and 90%. I don't really want to go too much into that, but there's a lot of overhead to really kind of train your models. Especially kind of with new tendencies as reinforced learning, having the human back into the loop when basically your confidence is not high enough, or with modified iterations, you can think about that this very simplified examples is becoming very big very quickly. Now, this edge case example and kind of an unexpected example, and there are other biased examples from which we heard this morning, is a good one. So this is pretty old, I think by now it's kind of 3 years old. But we have seen other problems with kind of self-driving cars before. But if we take this example, there were multiple news articles and multiple incidents with Tesla software that it, for some reason, didn't kind of account for deer. And so if we're kind of taking this deer example and you're a machine learning engineer at even a kind of competitor or another OEM, and wake up in the next morning, you kind of have maybe your boss coming to you and ask you, have we accounted for that? And I stole that very nice comic from a very great blog by Felix Friedman and team, who were talking about autonomous driving pretty publicly. They were You can Google them, what company in Germany they're associated with, but this comic basically illustrates it. If you don't really have an answer, or if your data is not centralized, as in this first kind of example, you kind of fail already, right? So if every machine learning engineer has their data set and their kind of approach locally, that doesn't really bring you further to answer your question, did we account for the deer accident? Do we have data? And then similarly, for kind of filtering and traceable or traceability, kind of how can we filter down, do we have the right data? Did we train on the right data? Did we have the right instructions? Did our model perform right when we basically trained for night scenes in this case? All of this kind of requires ultimately some kind of database or some kind of proper data management. Now, I'm asking the question basically, or I asked myself the question, and in our talks with our clients, this is coming up every now and then, and we're kind of actively contributing to that. How does an engineering organization increase their data insights in their pipeline? How can they ensure that we, over periods of time, we make sure that we actually know what we're working on? And especially if things scale, and we have currently projects of more than 300 people working on this, you can think about the throughput per day on images which are going out. So how are we ensuring that? And how does kind of our client base and our machine learning engineers ensure that they know what we're working on? And my biggest point this year is kind of going back and think about a database-driven approach to this, and kind of think about how you can standardize the metadata around this. How can you kind of capture data which helps you to filter down your data sets, and even on that, at some point, apply machine learning to. What I would also say is kind of accounting for iterative kind of scenarios, and that's easier said than done, but when we go through this pipeline, we have a lot of feedback usually, and a lot of cases you haven't been accounted for, so kind of being as flexible and agile in your approach definitely helps you as well. And then, in my opinion, finding a strong annotation partner, even though they may not necessarily always agree with you, but can challenge your ideas and concepts, is also something which at least my team does in most cases, kind of pushing back hard if we don't agree with a very objective approach, because usually these cases, especially in vision, are not as objective as one thinks. What's my learning for us, and how should we, as kind of a labeling industry, annotation kind of company industry, help or kind of contribute to this process? And I think it's very similar to kind of the approach I've outlined for the machine learning teams, is trying to make sure that we kind of, on top of the actual labels and on top of the actual training data, deliver metadata on it, and that metadata reaches from the quality, which is sometimes difficult to measure, but at least having some quality framework which you can kind of send back. And in addition to that, I think weather data, or basically kind of having just high-level attributes to each image which is going through, or each 3D scene which is going through our labeling processes, sending that back will help to kind of build that big database of what do I actually have in store, and kind of ultimately help you to kind of focus your future iterations of the machine learning model. And then we are constantly giving feedback, constantly making sure that there is kind of this bridge between the machine learning engineer and kind of the actual workforce who is doing that, because ultimately there will be an information imbalance at some point. 300 people versus one, or a team of maybe 5, they will definitely know more at some point about your data. And then I use whatever flexible while scalable. That's the most tricky piece. How do you scale while being flexible on it? What I've learned over the years is there's not really a one-size-fits-all templated approach. What can be done, however, is learning from your past and basically trying to kind of aggregate information as well, and kind of avoid some of the pitfalls you had in previous kind of runs. Now, this is kind of an example, again, very simplified, but what I try to kind of express here is that your main labeling pipeline should be surrounded, in my opinion, and a lot of companies are going this way these days, is by the requirements, so basically requirements being basically updated and validated and kind of reconstructed as you go through the pipeline by through every single step. And then similarly, what I talked about from a metadata perspective, making sure that you're tracking every step in a database and you actually know that that you're currently running the 5th iteration of a certain kind of guideline, which may impact your model afterwards. And I'm happy to talk more. We have a booth over there. I'm going to be around, so if someone has some more detailed thoughts or kind of has interest in discussions around it, happy to discuss that. But again, the main piece here is it's surrounded and it has an umbrella of requirements and insights supporting it. And then maybe what I would like to kind of leave you with is kind of a Google Trends analysis, and I'm stealing that again from an idea Felix had. It's kind of looking at kind of the buzzwords, something like semantic segmentation versus data set management. And I just filtered it for Israel, but don't worry, it's the same in Germany, it's the same in the US. It's like no one really cares right now about data set management. And you could ask, is it because it's all known, or is it because I haven't really thought about? And my kind of hope for a takeaway here is kind of thinking a little bit more about kind of the more boring stuff, but making sure that we kind of have a system where we can kind of categorize and classify the metadata through our project a little bit better, so we can keep track of our iterations of machine learning and increase the insights ultimately, which we can gain from what happens and can react quicker if something happens which is not necessarily how we anticipated it. And that's basically it from my side. Thank you for listening. I know it's lunchtime, and not yet. But yeah, thank you very much.